In the last video, we explored how LangGraph lets your AI not just think, but act. We saw how to connect tools like addition, subtraction, multiplication, division so that the model could reason, calculate, and decide its own next steps. Now, we're taking that idea even further. In this video, we're building something more practical, a document editing agent powered by LangGraph. We'll call it an email drafter, your intelligent writing assistant that can update, modify, and then save document automatically using AI and tools. But before we jump into the code, we'll try to understand what's happening conceptually. Here, our agent can combine LLM reasoning using Gemini, tool nodes for doing real-world actions, and conditional graph control to keep interacting until the document is saved. We'll define two tools here, update and save. Update to modify the document content dynamically, and save to store the final version into a TXT file. The system prompt that we're going to provide will ensure the AI always knows what the current document state is, and the LangGraph manages when to loop or exit depending on whether the user has saved the document or not. This structure will make your AI truly stateful, capable of handling multiple user interactions over time, and goal-oriented, something that's much harder to achieve in plain LangChain. By the end of this video, you'll see how LangGraph turns your language model into a functional writing agent, one that just doesn't respond, but works with you to create and save real content. So, we'll dive in and bring email drafter to life. So, I'm going to create a new file here. Call it email drafter.ipynb. Write down the imports. Okay, we'll load the credential first, and then we'll also define our LLM here. Run this. And then we'll have a global variable, to store document content. So we'll write document content equals to an empty string. Now we'll have our agent state class. Any other messages will be of type annotated, sequence, base message, and then add messages. Now, as I said, I'm going to define two different tools here. So the first tool will be update. We'll have a string content inside this, and then we'll also return a string content here. So I'll write down the doc string. Sorry for this. So this is going to update the document with the provided content. Update. Okay, so I'll access the global document content here. Then what I'm going to do is document content equal to the content that I get here, and then I'm going to return a string here which says document has been updated successfully. The current content is document content. Okay, so this is my first function or my first tool function that I have. Next, I'm going to create another tool called save, where I'll provide a file name in string format, and then I will return a string here. Write down the doc string, save the current document to a text file, and finish the process. The arguments that I'll be passing here is the file name, so which will indicate the name of the text file. So again, I'm going to access the global document content. Then if there is no file name created, then I will provide a file name .txt file here. Then I'll try to open this file. As file, and I'll try to write the document content into this file, and then print document saved successfully as file name, and then also return the same. If we have an exception, then I'm going to return an error message here. Okay, so these are my two tools that I'll be using. Finally, I'll create a list of my available tools. So the first one is update, and then the second one is save. I am going to bind my tools, or bind the LLM using my tools. So my tools, and then I'm going to create a tool node object using my tools here. Okay, now I need to define my nodes. So our first node is going to be our agent. It will contain agent state type. It will also return an agent state. So what I'm going to do here is I'm going to provide a system prompt. Let me just copy this prompt from somewhere. System. Okay, I'll just copy this entire thing from somewhere so that you can pause the video and then see what the actual prompt is. Okay, so the prompt is you are an email drafter, a helpful writing assistant. You're going to help the user update and modify document. If the user want to update or modify content, use the update tool, and then if the user want to save and finish, use the save tool. Okay, so this is done. The current document content is also passed here. After this, what I'm going to do is I'm going to check if user message is not provided, and based on this I am ready to help you update a document. What would you like to create? Okay, this is the first message that the user will be seeing, and then I am going to encode this inside human message, or else if there is already some content that has been generated, then the user input is going to be, so this should be an input. What would you like to do with this document? Then I will print user and then print the user input. Then put it inside the user message again. Okay, now these two states are done. What I'm going to do is I'm going to combine the system prompt as well as the user message that we have. So this will go inside all messages. It will have system prompt plus list of state messages plus user message. Now I'm going to invoke the model response equal to model.invoke. Invoke using all messages. Sorry, it's model here. Okay, then I'm going to print out AI response here. Or just write down AI and then print out response.content. Now I'm going to check if there is any tool calls provided in this particular response. So if has ttr response tool calls and response dot, sorry for the autocomplete part, response dot tool underscore calls, then I will print which tool is being used right now. So invoking tool, please be careful with the brackets here. So, tc tool name or tc in response dot tool calls, and then I'm going to return the messages which will be the list of state messages plus user message as well as the response. Again, I think I missed a bracket here. Okay, this one extra bracket extra. Okay, so this is done. So this is for our agent node here. Now I'm going to create a router node. So router node will be shared continue. It will contain agent state and then it will return a string. So the doc string for this determine if we should continue or end the conversation. Okay, so first of all, access our state messages. And then if there is nothing, then we should continue, or else if there is something inside this, then we reverse the list and then check the instance and see if it is save or like if the tool call name is present is in the form of save, so is instance message, it is message, right? Okay, some message, and then tool message. I think the spelling is wrong here, so for each instance message and then tool message, and saved in message dot content dot lower. Still this is not complete. And document in message dot content dot lower, then we return end, or else we return continue. Okay, so our router node is also fixed. So what we're basically saying is if we don't have anything, then we should continue. If we have save, then we should end the flow, or else if we don't have save, or like if we have update, then again we should continue the flow. Okay, so this is done. Save this, call our state graph, add a node, this will point to our agent, add another node, I'll have tools. Now I'll start adding edges. So from start we go to agent, and then from agent we go to tools, and after this I'm going to add conditional edges here. We'll start from tools, we'll go to should continue function, and then from should continue function we have two options. If we have continue, we go to agent. If we have end, then we end our flow. So let me compile this graph.compile, and then print out our state graph here. So as you can see, we start from here, we go to agent, we go to tools. If we have to keep on updating our document, then we continue this particular loop here from agent to tools, and then tools to agent. And then once we call the save tool, then we go to the end of the conversation. Okay, now I'm going to create some function for prints. So print underscore messages, it will contain our messages. Inside this function made to print the messages in more readable format. Okay, so if not messages, we just return. If nothing is there, we just return empty. But if we have messages, and then we specially focus on the last three messages that we have, then what I'm going to do is I'm going to check if is instance message is a tool message, then I'm going to print out tool message result.content. Now to run the document agent, I'll create a new function. So at first the state is going to be messages and then empty message. Then let me run this. So first step in bot.stream state, if messages in step, then print messages, step messages. and then it's done. And then at last, we can print out conversation ended. Okay, so let me run this. And then finally call run document agent. Now if we run this, so what it asks me is, I'm ready to help you update a document. What would you like to create? So write me a leave requesting email for 22nd October, sorry for the spelling, October 2025. Write me an email. Okay, the AI says, what should the email say? It should be about leave application. So the AI agent does write me an email. Now I want to replace the start date, replace start date to 22nd October and end date to 23rd October 2025. Let me save this file directly. Or I can say the email should include my name as Abhi, and then it does replace my name here as Abhi. So everything is done. What I need to do is I need to save this file. So if I say save the file now, save it. So it asks me for a file name, so I can say email draft, and then if we see somewhere in our folder location, then we see that we have an email draft file where the AI generated content is saved here. So this is all about the email drafter application. I've made a few changes here in this particular part here, as well as in this particular cell here. So please go through the changes, and then I hope it runs on your end as well. So in this video, we've seen how we can use LangGraph as well as our real world AI model to invoke the tools that we have and then do something meaningful for us. So that is all for this video, and I'll see you in the next one.